let's talk about the phases of matter, or states of matter. In a solid, the molecules, or in this case the atoms, are very close together and they're kind of locked in place. Each one is kind of vibrating in place, but they don't change their position relative to each other. In other words, an atom up here is not going to slide past the others and work its way down to this position. They're vibrating in place. In a liquid, the particles are a little further apart and they can move past each other. They're moving around, and a molecule or an atom that is up here may slide down and end up at the bottom or whatever. In fact, there's more random motion than you might expect. These are moving everywhere all the time, but they remain in close contact in a liquid. In a gas, the particles are much further apart. In fact, in this diagram, I'm not really showing them far enough apart for how large they are. So this is not to scale, but they are bouncing around randomly. There is very little contact, and truly, they are attracted to each other, but they're so far apart they don't feel that attraction. It's like when you have two magnets that are too separated, they don't attract to each other, they don't snap together or anything. Now, if you did compress this gas and you moved all these down together, or where they're close to each other, if you got them in close contact with each other, that attraction may take hold for a little bit, and if it did, they would become a liquid for a while. Okay, so one thing that I've brought up as I go through this is that in all cases there's movement. In the solid, the movement is just vibrating in place. In the liquid, it's sliding past each other but remaining close. And in the gas, it's more random, just bouncing around, not a lot of contact. The attraction is important because that's why we do have solids. If the particles weren't attracted to each other, all matter would be gases. Because if you can imagine, these particles are vibrating in place. If there was nothing making them attracted to each other, they would just kind of push away from each other until they became a gas. Okay. There's, like I said, there's even attraction in the gas phase. It's just they're so far apart they don't feel it. And in fact, when we study gases, sometimes we assume they're not really attracted to each other. The other thing is, in all cases, there was motion. So, motion and attraction. Okay, now we're going to look at some phase changes and the names. So you will need to write this on your own paper. You can pause it if you don't have some ready. Write it on the back of something. Let's see. Over here with the solid, if I have a solid and I warm it and it changes from solid to liquid, we call that melting. A fancier word for that is fusion. Okay, if we take our liquid and we heat it some more, we can get a gas. Liquid to gas is called vaporization. That is the general term. Vaporization can either be evaporation, where this phase change occurs on the surface of the liquid, or it could be boiling, where it becomes a gas under the liquid, making it have bubbles. Okay. If we go directly from a solid to a gas, that is what's called sublimation. In the winter, if you have some ice outside and it's got dry air, or even in your freezer, if you have some ice that's in there for a while, it'll kind of seem to disappear. It'll kind of shrink, and that's because it's undergoing sublimation. Okay. Notice all of these involve heating the substance to make the phase change happen. So let's consider the opposite reactions. If we have a gas and we cool it, like water vapor, and we cool it, we can get a phase change called condensation. If we have a liquid and we cool it, we can get a phase change called freezing. And then finally we could do the whole thing from gas to solid in one step, and this is called deposition. Okay, so those are the names. Again, the things that I wrote in red, these involve the substance absorbs energy. And the ones I wrote in blue, the substance, the water or whatever you're talking about, releases energy. I abbreviate energy with a capital E quite a bit, so if you see that in the future. Okay, so sometimes when people look at freezing, they think, well, that is not a physical reaction that releases energy, because when water freezes, no heat is given off. It seems like nothing's warming up, but the water is releasing energy, and what's happening in your freezer is that the water is releasing the heat, and the refrigerator or the freezer's job is to take the heat out of the freezer compartment and put it out into the room. So a lot of times in these phase changes that involve releasing energy, you don't see a temperature change because the heat is going somewhere else or into some other form. To keep these straight, remember the red ones all involve absorbing energy, so you heat a substance to make these happen. The blue ones involve releasing energy, so we think of that as we cool the substance, which just means we're taking heat away from it to make these happen.